record that first section. Okay, so now let's go to the next page. You'll see on the next page, we're going to start talking about the greatest common factor of polynomials. So the first section here in this worksheet on the second page of that greatest common factor worksheet link, it says find the largest integer. Find the largest integer that will divide in all the terms. Okay, in math, in general, the definition of an integer, hopefully you all know that integer means number. Number. What is the largest number that will divide into all the terms? So I'm looking at 9x, the term 9x, and the term 45. What's the largest number that will divide into both of these numbers? So here I'm only going to look for this section at 9 and 45. What's the largest number that I can divide out of 9 and 45? So I tell my kids, well, what number's smaller, 9 or 45? 9 is smaller. Okay, so if 9 is the smaller number, will 9 evenly divide into 45? What's 45 divided by 9? Hopefully you all know that 9 evenly divides into 45. Okay, so the largest number that will divide into both 9 and 45 is 9. Because 45 divided by 9 is 5. Okay, so let's look at number 6. I've got 7 and 21. 7 is my smaller number. Will 7 evenly divide into 21? Yes, it will, because 21 divided by 7 is 3. So 21 is a factor of 7. Now, if you look at number 7, you'll see that you have 18 and 12. Will 12, the smaller integer, divide evenly into 18? No. You'll get a fraction, a mixed number, or a decimal, however you write it. So what you need to do is you need to create a T-chart. If you don't know the factors of 12 already, we're going to be creating T-charts. What are my factors of 12? I'm going to take the smaller number and say, okay, what are the numbers that will evenly divide into 12? Of course, it's always 1 and 12. 2 and 6, 3 and 4. And the closer that these two numbers come to each other, 3 and 4, that means that your T-chart is complete. Because if I continued writing on this T-chart, I'll show you what happens. I'm going to write in blue here. We would say, well, 4 and 3. And then the next number would be 6 and 2, because 5 doesn't evenly divide into 12. And then I'll say 7's not a factor, 8's not a factor, 9, 10, 11. Oh, but then I get to 12, and 12 and 1 is a factor. Well, you'll see that these numbers are just repetition. They just repetitively go up the T-chart. So what's written in blue there, you can actually stop at what's written in red, and your T-chart is complete at this point. So now you need to determine if these are all the factors of 12, or these are the only 6 numbers that will divide evenly into 12, what's the highest number that will also divide into 18? Well, we already said 12 wouldn't work. So let's look at 6. 6 is the next highest number. 6 will go into 12 2 times. 6 will go into 18 3 times. So that means that 6 is the highest number that will go into both. Okay, 3 would also evenly divide into both, but the reason why it's not 3 is because 6 is the greatest. 6 is larger than 3, and it will divide into both integers. Okay, so that's why 6 is the GCF here and not 3, because 6 is greater than 3. I'm going to do one more here. I've got 15, I've got 25, and 55. My smallest number is 15. My smallest number is 15. Will 15 evenly divide into 25 and 55? No, it will not. So let's list the factors of 15. We know it's 1 and 15. 2 does not evenly divide into 15. 3 will with 5. And 4 does not evenly divide into 15. 5 will evenly divide into 15, but then we're just going to start repeating ourselves. So these are the only numbers that will evenly divide into 15. We already said 15 wouldn't work. So let's look at 5. 5 will evenly divide into 15, 25, and 55. So that means that 5 is the largest number that will divide into all 3 integers. Okay, so that's how you determine the coefficient, the number of your GCF when looking at a polynomial. So now let's go to the next section. Find the largest degree of x. Find the largest degree of x that can be factored out of all the terms. What's the largest degree of x that can be factored out? So now we're going to look at our variables. We're going to essentially ignore the integers here and only look at variables. So in number 9, the same 2 terms, 9x and 45, I have an x, and then I have no x. So if I don't have the variable in both terms, I cannot factor out a variable. If there's no variable with the term 45, I can't factor out, I can't divide out a variable. So let's look at number 10. I have x squared, and I have x understood 1. My degree of x is understood 1. So my terms both contain the variable x. If they both contain the variable x, then that means that I can factor out at least one x. Now here it says, what's the largest degree that can be factored out? If I have 2 x's, if I have 2 x's with 7x, and I have 1 x with 21x, what's the largest degree that I can factor out, that I can divide out of both? I can only take 1. I can only take 1x from 21x, and I can only take 1x from 7x squared. I cannot pull out an x squared because I only have 1 x available in this term. So you're looking at your smallest exponent. The largest degree of x that can be factored out is actually the smallest exponent. The smallest exponent. So in this case, my smallest exponent is 1. Now looking at x to the 6th and x to the 3rd. I can factor out at least 1x. And what's my smallest exponent out of 6 and 3? 3. I can pull all 3 of these x's, and then I can pull 3 of the 6 of these x's. And number 12, I have x to the 3rd, x to the 2nd, and 1x. All of my terms contain x. And what's the smallest exponent? 1. So I can only factor out 1x. Okay, so that's looking at it individually. So let's look at what happens when I factor out that highest exponent and largest degree. So now we've got the 2 terms written as a polynomial. 9x plus 45. 9x plus 45. We already said that we can pull out a 9. And we can't pull out an x because the 45 term that's a constant does not contain an x. So the only thing that I can factor out is just a 9. So my GCF for this problem is just 9. 9 divided by 9 is 1. My remainder is x. Positive 45 divided by positive 9 is positive 5. So my remainder is positive 5. So what you're writing is the GCF, and in the parentheses, the remainder. So for 13, 9 is the GCF, and x plus 5 is the remainder once you divide out 9 of both terms. Looking at 14, 7 is the greatest integer that can divide into both 7 and 21. And we said that we can factor out an x, 1x. So my GCF is 7x. And what am I remaining with after I factor out a 7x? Well, 7 over 7 is 1. And then x squared divided by x. What do we do with exponents when we divide? You subtract. So what is x squared divided by x to the understood 1? 2 minus 1 is 1. Negative 21 divided by 7 is negative 3. And x over x is 1. And this is what my answer would be. My GCF, and after I factor out my GCF, my remainder is x minus 3. For 15, 18x to the 6th, 12x to the 3rd. This is where we said that our highest integer was 6, and our highest exponent was x to the 3rd. X to the 3rd. So our GCF is 6x to the 3rd. What am I remaining with when I factor out and divide out a 6x to the 3rd? 18 divided by 6, I'm left with 3. X to the 6th divided by x to the 3rd, 6 minus 3, I'm left with 3 x's. 12 divided by 6 is 2. And then x to the 3rd over x to the 3rd is 1. So I'm only having a remainder of 2 in that second term. Okay, and then the last one, number 16. Out of all three of these terms, we said that the largest integer that could divide in all three was 5. And then the largest degree that could be factored out was x, 5x. So our GCF for number 16 is just 5x. What is my remainder? 15 divided by 5 is 3. X to the 3rd divided by x, what's 3 minus 1? I'm left with 2. Negative 25 divided by 5 is negative 5. 2 minus 1, I'm left with 1x. 55 divided by 5 is 11, and x divided by x is 1. And that is what my answer would be, the GCF with my remainder. Okay, so that is how you factor out the GCF. I'm going to do one more. Actually, I'll go ahead and do 2 more. I'll do 2 more where you do all the steps in one. Okay, so I have 6x squared and negative 24x. Out of 6 and 24, 6 will evenly divide into 24. So my GCF coefficient is 6. I have an x squared and an x. So I can pull out a variable x. And my smallest exponent is 1. So I can only pull out 1 6x. Okay, 6x. 6 over 6 is 1. X squared over x, 2 minus 1, I'm still left with 1x. Negative 24 divided by 6 is negative 4. And x over x is 1. So that's how you do it all in one step instead of 3. And I'll do one more, number 18. I've got 14x squared minus 35x. 14 is smaller than 35. 14 will not evenly divide into 35. So I need to set up my T-chart. What are my factors of 14? What are all the numbers that will evenly divide into 14? Well, I know it's 1 and 14. 2 will evenly divide into 14 with 7. 3 will not. 4 will not. 5 will not. 6 will not. 7 will. But I'm going to start creeping up the right side of my T-chart. So these are the only factors of 14. We already said 14 wouldn't work. Will 7 work? 7 evenly divides into 14, and 7 also evenly divides into 35 with 5. So 7 is the largest number that will divide into both 14 and 35. I have x squared and I have x. So I can factor out an x. What's the smallest exponent of x? Understood, 1. So 7x is your GCF. What are you left with? 14 divided by 7 is 2. X squared divided by x to the first power, 2 minus 1, I'm left with 1x. Negative 35 divided by 7 is negative 5. And x over x is 1. So 7x times 2x minus 5 is what your remainder is, 2x minus 5. Okay, so that is what GCF is. The rest of this worksheet, 19 through 28, can just simply be practice if you want to practice GCF. And then on the PDF copy, there are the answers that you can check your work with. Okay, so difference of squares. Let me move on to the next level of factoring, which is difference of squares. Last week, I taught you how to multiply polynomials that were difference of squares, which an example of this would be x plus 7 and x minus 7. We had the same variable term, the same constant term, but different signs. Okay? This is how we identified a difference of squares when multiplying. And we said that we could skip doing all of these steps of multiplying these binomials because we know it's a difference of square. We could just simply say term number 1 and term number 1 of both binomials. What's x times x? X squared. And then the second term, positive 7 times negative 7 is negative 49. And we can stop there. Okay, so all binomials of difference of squares are, or all polynomials that are difference of squares when factoring is a binomial where your operation sign is a subtraction sign. So if you have a perfect square and a perfect root as your C value, as your constant value with a negative sign, that is a difference of square, and you can use this shortcut. The shortcut is positive 49. What is the root of 49? The square root of 49, if you type that in your calculator, you'll get is 7. So I know that 7 times 7 is 49. My variable in this case is A. You've got to pay attention to the A. So that means that my binomials is A plus 7, A minus 7. 64. What is the square root of 64? The square root of 64 is 8. My variable is A. So that's going to be A plus 8, A minus 8. 144. What's the square root of 144? The square root of 144 is 12. My variable is P. So my two binomials that I'm factor out is P plus 12, P minus 12. I have different signs. Same variable term, same constant term, different signs. Number 4, 25. The square root of 25 is 5. You can use a calculator for this if you don't know that. My variable is B. B plus 5, B minus 5. Okay, so that is when you have a difference of square. Now, if you scroll down here and look at number 11 and 12, number 11 has a coefficient in the first term and the constant term. So what's the square root of 4? Square root of 4 is 2. What's the square root of 25? Square root of 25 is 5. And my variable is x. So my binomials are going to be 2x plus 5 and 2x minus 5. What's my square root of 16? Square root of 16 is 4. What's the square root of 1? Square root of 1 is 1. So my two binomials are going to be 4, my variable is b, 4b plus 1, 4b minus 1. Okay, I'll do one more like that. What's my square root of 9? Square root of 9 is 3. What's my square root of 4? Square root of 4 is 2. My variable is a. So my two binomials are going to be 3a plus 2 and 3a minus 2. Okay, so that is the difference of squares shortcut. Okay, that is difference of squares when factoring difference of squares. Now we've got factoring perfect square. Perfect square. So if you notice that this last term is also a perfect root, however, we now have a trinomial with the perfect root. Well, what happens when I have a trinomial with the perfect root? Well, what that means is, what's the square root of 121? Square root of 121, if you type that in your calculator, you'll get 11. It's positive 11, negative 11. Okay, technically when you take the root of something, it's positive, negative, that number. So positive 11, negative 11. At this point, this is when you've got to look at that middle number. What middle number do you see? Positive 22. So positive 11 is what we need. We need positive 11. So my two binomials are going to be x plus 11 and x plus 11, or written as x plus 11 squared. So your answer is x plus 11 squared. Okay, I'm going to do a few more of these. I have a perfect root, 36, because I know the square root of 36 is positive 6, negative 6. I need positive 12. I'm having to add to the middle number. Multiply to the last number, add to the middle number. So I have positive 12 in the middle, so I need positive 6. So I'm going to have x plus 6, x plus 6, or written as x plus 6 squared. Okay, my last term in number 3 is 9. I know the square root of 9 is positive 3, negative 3. My middle number that I need to add to is negative 6. Negative 3 and negative 3 makes negative 6. So my binomials are going to be x minus 3 and x minus 3, for my answer to be x minus 3 squared. Okay, I'm going to do a couple more. Square root of 1. I know the square root of 1 is positive 1, negative 1. I need to add to positive 2. Positive 1 plus 1 is positive 2. So x plus 1 times x plus 1 is x plus 1 squared. And the last one, 36. I know 36 is the perfect square of plus 6, negative 6. I need to add to negative 12. So I'm going to need negative 6. X minus 6, x minus 6 to x minus 6 squared. Okay, so that is the perfect root. The way that you recognize perfect roots are if that last term in your trinomial is a perfect square. If it's a perfect square, 121, 36, 9, 1. If you can take the root of that third term and you double the root number to get the middle number, you add to get that middle number, that means it's a perfect square. Okay? So your answer, when you pull up the PDF, your answer sheet is on there where you can double check your work for extra practice. Okay, so those are the last 3 or the first 3 sections.